the infrared spectrum are manufactured. Thermal sensing capability.
Do you copy? I don't have eyes on the target.
Copy that. We're in trouble. I think their tanks are equipped with night vision. Over.
In the next few minutes, we're going to reveal to you one of Israel's secret strategic advantages. Feel free to look around in all directions, but remember, what you see is for your eyes only. Welcome to SCD, a leading international developer and manufacturer of infrared detectors. Here, sophisticated night vision detectors, which are integrated and adapted for detecting light in all areas of the infrared spectrum, are manufactured. Thermal sensing capability is a tool that, as we've seen, can tip the balance in battle. But how is such a strategic advantage achieved? The secret lies in the technology that is being developed in the advanced laboratories of SCD, into which we are now entering. The development of some of the most advanced technologies in SCD begin here, inside the molecular beam epitaxy machines. The ultra-high vacuum inside these machines, which is comparable with the vacuum in outer space, allows us to grow layer by layer thin crystal wafers with an atomic resolution. At SCD's fabrication halls, Fab, a large variety of processes take place. Each of them is specifically designed for manufacturing different technologies of infrared detectors. In our fab, we process wafers of multiple sizes and substances, which by itself is a major technological challenge. These high levels of purity and precision are essential for growing the high-quality wafers needed to produce SCD's state-of-the-art infrared sensors. At this stage, the wafer is spin-coated with a UV-sensitive material, photoresist, creating a thin film on top of the wafer. We expose the coated wafer to UV radiation through a mask using a photolithography tool. Only the exposed areas of the photoresist film are dissolved, leaving a patterned photoresist on the wafer. Photolithography is our method to transfer every detail we want from the designed mask onto the wafer. Alongside the production of infrared IR-sensitive wafers, we work on the readout integrated circuits, ROIC, wafers. Later, the wafers are diced into dies. Every wafer is processed in several cycles of photolithography, followed by one of the following processes: dry or heat etching, thin films dispositions, or evaporating processes. Many cycles are required to complete an IR wafer process. It may take many weeks or even months to complete a full IR wafer process from the very beginning until completion. From here, after delicate polish processes, only the FPAs that reached optimal condition can continue to one of the two assembly lines, cooled and uncooled detectors. The assembly process is designed to connect the FPAs to the outside world on one hand, and yet keep it isolated at optimal working conditions, regardless of the conditions outside, whether it is exposed to the elements, heat, cold, moisture, or rough physical conditions, vibrations, shocks. Most of our detectors need deep vacuum to work. The vacuum is needed to thermally insulate the cooled sensor from the outside world and to remove volatile materials from the detector parts themselves. After this process, the detectors will reach the final characterization. Here, the detector images are checked to make sure they meet all the specifications before being sent to the customer. The move towards multidisciplinary production of products was led by a collaboration of teams from the engineering, R&D, production, QA, logistics, and other departments as well. The team of expert staff is busy developing and maximizing the technology. They are committed to provide a product with the highest standards, and at the same time, they develop the products of the future. Our employees are actually the most critical assets we have in the process of manufacturing and improving our detectors. So where are our detectors being used? The applications are versatile. In the military there are, for example, night vision goggles, drones, missiles, surveillance systems, commander and gunner sights, anti-missile warning systems, and more. In the environmental area, there are OGI, optical gas imaging detectors for detecting gas leaks. In the industrial area, there are systems for smart agriculture. There are even some SWIR detectors right in front of you in space. The detectors can withstand the harshest conditions and can be adapted for any use. Thanks to the knowledge, technology, and innovation of SCD, you can be sure that a solution to every need will be found at the moment of truth. Thus, SCD decides the battle.